let's take a look at exam review practice problems number 2. I hope that you guys had the time last night to look at this really closely yourselves and took advantage of some good practice opportunities. This first practice problem looks at data tables and how to make sure that they are really communicating what you want them to be saying. So let's start here with the title. The title of this data table has some issues. Every title needs to have both your independent and your dependent variable. So in this case, we would be looking at how the amount of water flowing affects the amount of suspended sediment. Far better showing the effect of one on the other. Second correction here is looking at our independent variable. We want to make sure that it doesn't just say that it's the water, but it's the amount of water, and specifically we're measuring that in gallons. Units are required for both your IDV and your DV if there are units present. Third, we have raw data. Remember, raw data is any data that is collected in the field, any data that you use a tool directly to measure. In contrast, over here we have our derived data is any data that has been calculated. So here you see our two options. We have total mass of sediment in grams and average mass of sediment in grams. Notice if you're looking at our total, that would require you to add together our first, second, third, and fourth trial in order to get a total mass of that sediment. You see those equations are here added at the bottom. Total mass of sediment equals the sum of 4 trials for each treatment. Our second set of derived data is the average mass of the sediment. As we've seen before, our average mass of sediment is when you add up 1, 2, 3, 4 trials. So you add up each of your trials and then divide by the number of trials that you have. So in this case, we would be dividing by 4. Our next correction is simply adding units to our dependent variable, so the mass of the sediment is measured in grams. And finally, we like to have our values always moving in ascending or increasing order. So change this from 0 to 20,000, have this be 10,000, then 20,000, 30,000, and so on. Moving on. From this data table, you're able to glean a lot of information about your experiment. So first we see that our independent variable is the amount of water flow in gallons. The water flow is affecting the amount of sediment in that water, so the mass of the suspended sediment in grams. Notice that that word suspended is important because we are not collecting the sediment from the bottom of the stream. Next, we have our treatments. In this case, there were 5 treatments that I was able to identify by looking underneath my independent variable. So 0, 20, 10, 30, and 40,000 gallons of water are my treatments. Our control group would simply be the minimum, so the 0 treatment, 0 gallons of water, and all of the other treatments would be my experimental groups. So again, not including my control, all of the other groups, 10,000, 20,000, 30,000, and 40,000 gallons of water. In this situation, there are 4 trials. That should be pretty clear from the data table looking at trial 1, 2, 3, and 4. If we take the number of treatments that we have, which is 5, and multiply that by the number of trials, that will get us our answer for number 10, the number of trials for the entire experiment. Next, we look at our baseline, and unless you see an original or starting measurement, there will be no baseline from a data table. So in this case, there is no starting, so there is no baseline in this situation. I hope that this was helpful for page 1